Bienvenidos, Hushamdi, and welcome to this Hut 8 networking techtorial on the Cisco Networking Academy Enterprise Networking Security and Automation course, part of the CCNA version 7 curriculum. In this Packet Tracer activity, we're going to be taking a look at Packet Tracer 2.7.1, which is the Single Area OSPFv2 Configuration Challenge. Now, this is one of my favorite type of Packet Tracer activities because it's going to require us to go deep into our OSPF toolkit and recall and leverage all of the OSPF information that we've learned to this point in the course. All right, so let's go ahead and dive in and take a look at our topology here on the left-hand side of the screen. You can see that we definitely want to buckle our OSPF chin straps for this one. We're going to be configuring 6 different routers. We've got a number of tasks. There is the addressing table for the activity if you wish to try to replicate this in Packet Tracer. And here are the requirements. We're going to be using process ID 10 for OSPF activation on all routers. And so here's how I'm going to work through this activity. I'm literally going to tackle things step by step. So the first thing I'm going to do is we're going to come over here to P2P, or point-to-point number 2. We're going to go into global config, and I'm simply going to say router OSPF 10. Now, let's step over to P2P3, and let's make sure that we get a good solid foundation set up here. So we'll say router OSPF 10, knowing that we have the correct OSPF process ID number configured on all of these routers. So router OSPF 10, router OSPF 10, router OSPF 10, and finally on BC1, which is our autonomous system boundary router as well. It's going to be our gateway to the internet. All right, so now that process ID 10 has been activated on all routers, you'll notice our completion percentage is still at 0. And that's because all of these tasks are where we are going to actually earn our points. Now, the first task that's listed here after the ID, the process ID of 10 task, is to activate OSPF using network statements and inverse masks on the routers in the headquarters network. And again, this activity did not exist in the version 6 curriculum, and what I really like about what they're doing here is they have us using the network statement for the headquarters network, but then they turn around and have us configure it on the individual interfaces with the IP OSPF command. So I really like how they're doing this. The previous version 6, only showed you how to do things with the network command and a wildcard mask. So in the headquarters network, let's just walk through each of these routers here, and let's activate and enable the OSPF process on the interfaces that belong to P2P number 2. So I'm already in the OSPF config, and again, we're using the network statement, but I'm going to say do show IP interface brief, and let's make sure that we see that we do in fact have 4 networks configured here. Now, we can easily see the CIDR notation, the subnet identifier, and the mask for all 4 of the network segments. So the /24 is always the easiest. 0.0.0.255 for the inverse mask or the wildcard mask. For /30, sometimes that poses a little difficulty. And I like what they've done here. They haven't given you the dotted decimal notation subnet mask. They've given it to us in CIDR notation. So now we need to use our subnetting skills in order to figure out what the wildcard masks will be. And not only that, but first, what the subnet mask will be in dotted decimal notation. So again, we've talked about the /24. That's easy. Very low-hanging fruit there. But what about the /30? Well, remember, the first 8 bits in the first octet and the second octet and the third octet, that's 24. And so that means we've got 6 bits here in the 4th octet, these are all your network bits. Now, if there's 6 being used in the 4th octet, that means that 2 are not being used. And so if all of them were being used, it would be 255. If I take away the 1, it's 254. If I take away the 2, and remember, we're saying that the 4 position, the 8, the 16, the 32, the 64, and the 128, these are already assigned for network bits. So this position is worth 1, so I'll subtract 1, and then I'll subtract 2. And when I do that from 255, I end up with 252. So remember, the subnet mask in dotted decimal notation for a /30 is 255.255.255.252. Now, to get the wildcard mask or the inverse mask, you simply subtract the dotted decimal notation subnet mask, which is, and I'll just say 255, 255, 255, 252, and you subtract that from the all 255s. Makes it very easy to look at this now. So if I put the line here now, we can simply see that that is going to be 3. So we'll have 0.0.0.3. And remember, these were just this shorthand for 255, right? I'm not going to didn't want to write it out 6 different times. So we've got our inverse or wildcard mask. So let's jump into the configuration here. We're already in the OSPF global configuration section here. And so now let's just add these network commands in. So we'll start with 192.168.1.0. And again, everything's area 0, and you can see that indicated here. I don't see it listed over here in the instructions, but we clearly see that this is all going to be area 0, or the backbone area. So that's the network command for the 192.168.1. Here's the command for the 192.168.2. And now let's drop it in for the 10.0.0.0. And remember here, it's a /30 or a 255, 255, 255, 252. That is the inverse mask. But again, still in area 0. And then finally, the other point-to-point network. So now I've got my 4 network statements in here. Let's go ahead and step over to P2, P3. And again, we're going to do much the same thing, except just a little bit quicker here because we already know what we're going to be doing. Oops, sorry, .255, area 0. Now I need 2 network statements for the 10.0.0.8 /30 subnet mask length, area 0, and then for the 10.004. So if I say do show IP interface brief, those are the networks 1, 2, 3 that we have set up. Do show run section router OSPF, and we can see we've got our 3 network statements, and we've even had an adjacency that has now popped up. Now let's come over here to P2P number 1. We'll add our network statement in for the 10.0.0.0 /30. And then for the 10.0.0.8. Whoops. Left off the 8 there. Looks like it put me at the end as it was putting the output to the screen. It dropped it to the end, and we should see another adjacency come up here. And now we're also going to add in the final network, which is the 10.0.0.12 that takes us over to the data services network that is going to allow us to reach that autonomous system boundary router located right here. And this ASBR is an ASBR because we're going to be redistributing external routing information from another protocol. In this case, it's going to be the static protocol. All right. So we've got our network statements, do show run section router OSPF. And we can see that we've got our config squared away there. So now let's come down here and read the next step. It says activate OSPF by configuring the interfaces of the network devices in the data services network where required. So again, we'll start here on BC2, and I'm doing this intentionally because by the time we get to BC1, who later on we're told we need to adjust the OSPF priority so that that router is always the designated router. We're going to see what happens when the wait timer has expired. So here you can see we also need to set the router ID. So I'm going to kind of piggyback the task of activating OSPF off of the router ID because we're already in the OSPF global configuration stanza. So on BC2, let's set the router ID to the 5.5.5.5. And then let's go into interface, and actually let me see, do show IP interface brief. It should be gig000. And we'll say IP OSPF 10 area 0. We'll go into interface Gigabit Ethernet 001, and we'll just hit the up arrow and we'll reissue that command. And so that takes care of the steps required on BC2 to this point. Let's go to BC3. And so again, BC3, we'll set the router ID to the quad 4s. And then we're going to say do show IP interface brief, and it should be the same gig 000 and 001. And it is. So Gigabit Ethernet 000. Whoops, not yet. And we have to say IP OSPF 10 area 0. And then we go into int Gigabit Ethernet 001. Now, what we should see happen as soon as I hit enter here is we're going to see that an adjacency between BC2 and BC3 is going to be established. If I say do show IP OSPF neighbor, and right on schedule there, we are now fully adjacent with router BC2. And you'll notice who on this broadcast multi-access Ethernet segment that runs through this switch that's between BC1, 2, and 3, who is the current DR? Yeah, BC3 is seeing BC2 as the DR. And so again, we'll come back and address that a little bit later on, but I'm doing that intentionally to show you what you would have to do when something like what I'm going to show you arises. So we're on BC1 right now. So let's set our router ID to the 6666. And then let's go ahead and say do show IP interface brief. All right, so we're going to get into interface Gigabit Ethernet 000, IP OSPF 10 area 0. Now, this is going to bring BC1 into this broadcast multi-access Ethernet segment as an OSPF participant. And there we go. So as you can see, we now have adjacencies. Whether they're full or not depends. And again, they would be full from BC1's perspective because it is a druther. It will be a DR other because the DR and the BDR have already been elected. In fact, if I say do show IP OSPF neighbor, you can see that BC1 thinks that router BC2 is the DR and BC3 is the BDR. So if I come over here and say do show IP OSPF neighbor, you can see right now that BC1 is viewed by BC2 as a druther, and we should see the exact same thing here, OSPF neighbor, and that is that router BC3 sees BC1 as a DR other or a druther. Again, it's not the DR and it's not the BDR, so it will be a druther or a DR other. All right, well, we have activated and I apologize. Let me step back there. I went off on a segue. And so let me make sure here if I say do show IP OSPF interface brief, and the brief option isn't there. So it's only gig 000 that we've configured. But you'll notice we still have to configure interface, and it's a serial interface do show IP interface brief. And that is serial interface 010 with an IP OSPF 10 area 0. Now, this brings up the question about what do we do here with serial 011 that goes out to the 64.0.100.2. Now, remember, the 64 network is this transit segment here with the internet service provider cloud. So we're connected via a serial link to a service provider router, and that's going to allow me to get out here to the internet server. Now, am I running OSPF with the service provider? Probably not, right? And it clearly states here, where required. You'll notice that the where required statement is not here when we use the network command on this side of the topology. So for everything over here to the left, we activated OSPF on every router interface. There was no caveat where required. However, on the right-hand side of the diagram, and specifically when we're talking about this connection and that interface right there, is it required that we run OSPF there? And the answer is no. So we will not be enabling OSPF on that interface. And I would be shocked if we are supposed to do that and then passive that interface. But I will tell you there was another activity in version 6 where you had an interface that went to the service provider that they had you passive, and I can't remember if it was OSPF or EIGRP that was the routing protocol, but they had you put a passive interface statement for that interface, which didn't make much sense. I understand why they might have us do that. And that's to ensure that if, for whatever reason, this interface had the OSPF process started and on it, that we are not sending hellos out to the service provider. Because again, we would be giving away a lot of information in those OSPF hellos like we've already discussed. So again, we're going to be coming back to that because we've got some static routing information we're going to have to do. So all of the interfaces have been configured for OSPF in the data services network. The router IDs have been configured. So now it says configure OSPF so that the routing updates are not sent into networks where they are not required. And so here's where we're going to see if they want us to do it on that internet-facing interface, even though we're not running the OSPF process on that interface. But let's start over here. And again, as a review, remember that the passive interface command is a command that do show IP interface brief. It's a command that we use to ensure that the OSPF hellos that are being multicasted out to the 224.0.0.5 for OSPF v2 IPv4, we set the passive interface command so that those hellos are not sent. And the reason that we do not want the hellos sent out to that this network and to this network segment, or to that network segment, or to this network segment, or to that network segment, is because do you see any OSPF speakers down here? And the answer is no. We're not going to be establishing any OSPF adjacencies with any of the devices, and I guess I should draw that a little larger, with any of the devices down here, so we don't need the OSPF hellos to be generated and then propagated down into these network segments, because for a number of reasons. First and foremost, security. Somebody here could be running Wireshark, a bad actor in your company with nothing better to do, and then they could be capturing those OSPF hello packets. They're going to see the router ID. They're going to see the subnet mask length. They're going to see all of the networks that router is advertising, right? There's all kinds of information that's going to be seen in there, and the router ID being probably the most dangerous. Because if they start spoofing this router, we can have all kinds of problems. All right, so the other reason, and again, I think these are kind of secondary and tertiary to the security concern, is that you may have extra processing that has to be done by the router here, or by the nodes, the end nodes here on these different network segments that have to process that traffic. Well, okay, sure, given today's horsepower in both network speeds and feeds as well as compute, I'm not sure that that's going to be that big of an issue. But again, on slower links like this up here, and we'll talk about the change they're going to have us make on this network segment, very, very important, right? To consider, hey, it could be additional overhead and traffic out on that interface. All right, so let's go ahead then here on P2P number 2 and get into interface Gigabit Ethernet 000, and actually, sorry, router OSPF 10, and we're going to say passive interface Gigabit Ethernet 000, and then just come right back and say 001. Let's do much the same over here. We'll get into global config, router OSPF 10, and we'll say passive interface Gigabit Ethernet 000. Now, we're also going to take a look here. Do I need to passive any of the interfaces here? And the answer is no. If I was to put a passive interface statement in for any of these interfaces, the adjacencies over these point-to-point interfaces on P2P1 would go down. So no LAN-facing segment there. Let's come over to BC2 here, and let's get into the router OSPF 10. And let's say passive interface Gigabit Ethernet 000. And then finally, for BC3, and maybe a finally here, we'll see what happens when we go up to our ASBR. I'll say passive interface Gigabit Ethernet 000. Now, again, it's only because I've done a previous activity where there's a service provider cloud involved and an interior gateway routing protocol like EIGRP or OSPF being run that on the autonomous system boundary router. And let's watch the points down here. We're at completion percentage 55 right now. Let's go to router OSPF 10 and let's say passive interface and it's serial 011. Now, what this is going to show us is whether or not we needed to have a passive interface statement for that internet-facing interface. So from 55, sure enough, we go to 57. And this could be one of those gotchas, right? So again, I understand why they're doing it. And you could even look at this from a best practices perspective. That interface, we would never want that interface to be running OSPF. But what if, by accident, it got enabled? If you have the passive interface statement there, it guarantees that we're not going to have the OSPF hello messages being sent out that interface. Now, from the opposite side, we could also make the argument that OSPF isn't running. We don't need to have the passive interface statement on that interface, and I would be fine with that argument as well. So I think that both arguments have merit. However, if we're thinking about this from the perspective of what would be the best thing to do, it would make sense that we would throw the passive interface statement on there because, again, accidents happen. They happen all the time. When you're making configuration changes, the last thing you would want is for multicast packets being sent out to the 224.0.0.5 on this segment would take all of our internal, or a lot of our internal information, and send that information out, about OSPF that is, from the perspective of BC1. All right, so we got the 2 points, good to know. Now let's transition on to the next step. Now, configure BC1 with the highest OSPF interface priority so that it will always be the designated router of the multi-access network. Well, this now comes full circle to what I was talking about earlier when I said, well, what happens if I say show IP OSPF neighbor right now? And right now, BC1 is not only is it not the DR, it's not even the BDR. It is a druther, a DR other. So we've got our work cut out for us here, and I really like the way that Cisco phrases this question. Use the highest OSPF interface priority. It doesn't say set it to X. It's now going to see, do you remember what the highest priority value is? And if you don't, do you know where to find it on the CLI? So let's go ahead and do this and let's see what happens, right? I really, really like how they're having us do this here. Let's say do show IP interface brief, and it should be that int gig 000 interface. Now I'm going to say IP OSPF priority, but I don't know what the value. I know that 0 is the default for point-to-point interfaces or network types. What about 1 is the default for broadcast multi-access Ethernet segments? But what's the highest value? What if I don't know that? What do I type here? Exactly. We throw the question mark in. We get that context-sensitive help that's available to us right here in the interface configuration mode for this IP-OSPF command. And we can clearly see that, our memory's jogged, and yes, it's 255. So that means I'm the DR, right? Not only do I have the highest priority, but BC1 has the highest router ID value that we manually set. Because if the priorities are all equal, which they were initially, BC1 had the highest router ID. And now it's got the highest priority. And the priority is the number one determinant as to which router on the segment, given that all routers have not already transitioned through the wait timer. This value, the priority value on the interface on the broadcast multi-access Ethernet segment, is the number one determinant as to who will be the designated router. But we don't see much of anything happening here, right? What if I say, do show IP-OSPF neighbor again? Yeah, well, I'm still seeing BC2 as the DR and BC3 as the BDR. So what's the problem here? And if you remember the packet tracer activity we did with the 3 routers and the multi-access segment, the problem is that the wait timer, when we configured OSPF on BC2, and it knows that this is a broadcast network type, right? We've got 40 seconds at that point that we needed to bring everybody else online to see who was going to be the DR and the BDR for this multi-access broadcast network type segment here. But we didn't do all 3 of these routers in 40 seconds. What happened was BC2 waited the 40 seconds, didn't see probably saw BC3 who had a lower router ID, and BC2 was elected as the designated router. And because at that time they were the only 2 routers on this multi-access broadcast network type segment, BC3 became the backup designated router. We then, after the fact, configured BC1, who now just becomes a DR other. So now the question is, how do I get BC1 to be the designated router? Because maybe there's some points, completion points, that are waiting here. Now, I don't think that's the case. I don't think Packet Tracer is that intuitive that it's looking to see who the DR and BDR are going to be. I think it's just looking for the commands. But let's take this real world. I want BC1 to be the designated router on this segment. So how do we do that now? Well, if I clear the IP-OSPF process on BC1, is that going to do anything? And let's go ahead and say clear IP-OSPF proc, say yes. You can see everything goes from full to down, and now everything goes from loading to full. So show IP-OSPF neighbor. Nope. It doesn't do anything, right? And the reason being is, remember, the DR-BDR election, once it's done, there is no preemption, right? And you can think of it in terms of once things are set in stone, it's going to be that way until one of these routers crashes out or we reset the OSPF process like we just did on BC1. So here's what we're going to do. I'm going to come to BC2 and we're going to say clear IP OSPF proc. And then I'm quickly going to come over to BC3 and do the same thing. Do clear IP OSPF proc. And let's do it one more time on BC1 just to make sure here. Clear IP OSPF proc. Now, what we should see now is that BC1 should be winning this race. And let's say show IP OSPF neighbor. And it looks pretty good right now. It seems as if BC3 is the DR other or the druther. And this makes sense, right? BC2 is the backup designated router because BC2's router ID, because the priorities for BC2 and 3 are the same on this broadcast segment. It's 1, the default. So the higher router ID takes precedence. And the router ID is like the fingerprint. It's got to be globally unique throughout this OSPF configuration here on this multi-access segment that we've got. And so the priority value wins out and BC1 becomes the DR. Now, how else could I see this? What about that old show IP OSPF interface command? And I could even drill down to the individual interface so that it'll tell me on this segment who is the designated router. And you can see right there that I am BC1, who is the backup designated router. It's right there, BC2. And so we can see those values here. If we did the same thing, the same command over on any of these routers, do show IP interface brief. I think here it's the gig, it's gig, do show IP OSPF interface Gigabit Ethernet 001. And you can see the designated router is in fact the router with the router ID of 6.6.6.6. We know that that is BC1. All right, so we've taken care of configuring BC1 with the highest OSPF priority, and we ensured that it is now the current designated router on that multi-access segment. Okay, configure a default route to the ISP cloud using the exit interface command argument. So here's the internet cloud. We know that that interface is serial 0, I think it's 11, show IP interface brief, and it is serial 011. So let's get into global config and say IP route. We'll throw the quad zeros in here, serial 011. Now, we're probably going to see that packet tracer message that tells me that if this is not a point-to-point network, there could be some performance issues, but it is a point-to-point network. And there we go, or point-to-point interface. And so we are okay. So the static route has been configured. Next, it says automatically distribute the default route, that default static route, to all routers in the network. In other words, all OSPF speaking routers. So let's go ahead and make that happen. And we know that we go into the OSPF config and I say default information originate. Now, in Packet Tracer, there are no other options here, right? There's no always, there's no metric type, there's no metric, right? Arguments that we can use, but we know that those exist. We talked about them in the previous video. So if you need a refresher on that, you can always refer to that previous Packet Tracer tutorial. But that is the only command that we're going to need. Now, here is what's critical. Before I do this, let's take a look at some of these routers here. Let's say show IP route, and let's see, do I have a gateway of last resort? No. What about here on P2P3? Show IP route. Gateway of last resort not set. What about on BC2? We'll go into global config and say, don't need to be in global config. We'll be in privilege exec and say show IP route. Gateway's not set. So as you can see, the gateway of last resort here has not been set on any of these routers. So why is that important? Well, it's important because I want to show you something here on PC1. If I come to PC1 and I go to the desktop and we look at the config, the default gateway for PC1 is the 192.168.1.1. It's this interface right here on P2P2, right? So when I say ping or trace route, or I try to go SSH to an IP address, if I don't have a specific network statement in the routing table on this PC, then I'm going to send that traffic to the default gateway. Just like routers will send the traffic, if they don't have a more specific match, they'll send it to the gateway of last resort. And so right now, what do you think would happen if I tried to ping the 203.0.113.100? Yeah, we're going to get this destination host unreachable, right? And who's telling me that? Again, remember, that's coming directly from P2P2 because the traffic reaches this router, right? So we issue the ping command and the ICMP traffic shows up here. Router P2P2 takes a look at the IPv4 header information, sees the destination IPv4 address of 203.0.113.100, looks into its routing table and says, I have no idea how to get to that network. Not only do I not have a specific network statement for that network, I don't have a gateway of last resort. So there's nothing I can do with this traffic other than tell you that the destination host is unreachable. I have no route to get there. And so that's, again, why we see that message. So let's clear our screen here. And here's something interesting as well. But what if I was to say ping, and I tried to ping PC3? Way over here, part of the 192.168.5 network. What do you think is going to happen there? So we'll say ping 192.168.5.50. And so initially, it appears as if it's not going to work. We're going to get the request timeout, but now we're getting a response. So why is that working? Well, remember, if I come to my default gateway here, do I have a specific match on how to get to that network? And I absolutely do. And there it is right there. And it's an intra-area learned OSPF route. Because remember, we have a network statement on P2P3 that is advertising that 192.168, I'm sorry, on BC3 that is advertising that 192.168.5 subnet. All right, so now let's change it up here a little bit. Let's come back over here and we say default information originate. We hit enter. And now let's come over to P2P2 and say show IP route. And now what do we see? Now I do have a gateway of last resort. So let's rerun on PC1. Let's rerun this ping command here and see, can we make it all the way out? So the first one, request timeout, and there you have it. We now have end-to-end reachability. So let me check laptop 1. And we'll say ping 203.0.113.100. And we've got connectivity. In fact, if we were to go to any of these devices right now, and this is always a good check, .0.113.100, this is always a good sanity check to make sure that the configuration that you've put into place is actually, and sorry about that, I want to get out of here, is actually yielding the results that you would anticipate. All right, and even from the data services network, we have connectivity. And then finally, from this PC here, we'll ping out to the 203.0.113.100, and everything looks great. So we've automatically distributed or propagated, originated that default route to all routers in the network. And we know that to be true because we wouldn't be able to get to this 203.0.113.100. Now, remember, I also made a statement that this is an autonomous system boundary router. And the boundary is right there, right? Everything over here is not part of my OSPF autonomous system, right? Or my OSPF domain that I have here. So there's my boundary, and this is the router protecting that boundary. So how do we see that information? Well, we would go to BC1, and I could say show IP OSPF, and actually I don't want show IP protocol, show IP protocols. And we're going to see right down here where it says that this router, it is an autonomous system boundary router, an ASBR. Now, when you get into more advanced OSPF configuration like multi-area OSPF, you'll start to learn about area border routers, routers that border different multiple areas. And this is an autonomous system boundary router because it is a boundary for OSPF between OSPF and a non-OSPF routing domain, which just happens to be the internet service provider here. All right. So now it says configure the OSPF routers so that the gigabit Ethernet interface cost will be 10 and the fast Ethernet interface cost will be 100. Well, how can I check my costs right now? How would I do that on the router? Well, what if I said show IP OSPF interface? Would the cost be in here somewhere? And the answer is that it would. And you can clearly see here that the gigabit Ethernet interface cost right now is 1. We're being asked to make it so that it's 10. right? And here's the challenge with OSPF, and EIGRP suffers, and when I talk about EIGRP, we're talking about classic mode EIGRP, and what we're doing is we're using the whatever that metric calculation that's being done in the routing protocol is coming up with a cost. But the question is always, well, how is that cost calculated? Well, with OSPF, you would take 10 to the 8 and divide it by the speed of the interface, right? And so what happens is all interfaces there, and there's a default, and the default for the cost that it uses for that calculation, 10 to the 8 divided by interface speed, is 100 megabits a second. And you might be scratching your head saying, well, hold on a second. I mean, we've got 100 gig connections in our network, or 40 gig connections in our network, or 10 gig connections in our network. Why is it that the default cost is 100? Well, at the time OSPF was written, 100 megabits a second was seen as bleeding edge. And so that was the value that was used at the time. And as a result, the problem is that any interface speed over 100 megabits a second will have a cost of 1. So a gigabit interface is 1. A 10 gig interface is 1. A 100 gig interface is 1. And so you start to lose the resolution, right? The clarity, or OSPF starts to lose that clarity as to which path is the preferred path based on the cost. Because if a 100 gig interface has a cost of 1, and a 1 gig interface, like we see right here, has a cost of 1, OSPF says those are going to be treated as if they are the same speed, the same cost, because they are the same cost, right? But it treats it as if they're the same speed. They have the same capabilities, and they clearly do not. So what we're going to do here is we're going to make sure that FastEthernet and GigabitEthernet interfaces are going to have a cost of 10 and 100 respectively. And here's how we do that. We use the auto cost reference bandwidth. So I say a router OSPF 10 auto cost reference bandwidth, and I'm going to say, whoops, sorry, not 10. We're going to say 1,000. And if I was to back up here, you can see that the value we enter it in megabits per second, right? And you can see right now it goes up to 4 terabits a second, which is probably going to hold us over for at least the next 18 months. And of course, I say that jokingly, but it's going to hold us over for a while before we've got, terabit connectivity running through our enterprise network. So auto cost reference bandwidth in 1,000 megabits a second is a gigabit a second. Now, this is a very important note right here, this message that we see. Ensure that it's consistent across all routers in this OSPF area. And this is critical because we don't want this router calculating its best shortest path with auto cost reference bandwidth 1,000 and everybody else is using auto cost reference bandwidth 100, which is the default, right? So we want to make sure that all of the routers are performing this calculation in a uniform fashion. And so here's how we would make that happen. We would go to all of the routers, right? But first, let me save the config here and let me recall that show IP OSPF interface command. And let's see what we've got here. Whoops, sorry. And the cost did not change. And I'm wondering, hold on just one second. Did I do router OSPF 10, auto cost reference bandwidth 10, do show IP OSPF interface. And it's interesting that it didn't make the change there. And so I'm curious. It's giving me, now this is interesting. It's giving me the points for setting it to 1,000. And then I thought to myself, wait a second, I used the wrong value. But it's giving us the points there. And so I'm going to circle back to this. The Gigabit Ethernet interface cost would be 10. So for the Gigabit Internet, the Gigabit Ethernet interface cost to be 10, I typoed it. I should have said 10,000, but it takes the points away. Yeah, it takes the points away. So this is what I like to call a fortuitous failure. So I typed the wrong command and I left a 0 off because I was thinking gigabit Ethernet. And the cost for gigabit Ethernets will be 10. And so this looks like it might be a bug because you can see that the cost is 10, but the points are gone, right? When I had auto cost reference bandwidth 1,000, watch my completion percentage go from 68 to 70. But is the OSPF cost? So I think what the typo may be is that it wants that maybe the 0 is not supposed to be there, that the cost should be 1 for gigabit Ethernet and 10 for fast Ethernet. And it's either that they want the cost for gigabit Ethernet to be 1 and fast Ethernet to be 10, or if this is what they want, the grading engine is actually wrong on this router. And so I'm glad I put the wrong value in because I saw the point count go up and I'm like, wait a second, I think I just typed in the wrong value for 10 gigabit. So let's see what happens here as we make our way through if that is actually the case. So we'll go into global config and we will say router OSPF 10 and let's try auto cost reference bandwidth and let's try the wrong value of 1,000. And see if completion percentage goes from 70 to, I would assume 72 or 73. And it does. So that's very interesting. So if I say do show IP OSPF interface, what is that gigabit Ethernet interface cost? It's 1. And that's what it is and that's what it should be because we just set that as the reference point right there. 10,000 for 10 gig E that would be the correct command, but the problem is, and you can see we get the desired result there, and we would if there were fast Ethernet interfaces here. The problem is that it takes the points away. It's not giving us the points. And so be aware of that. I'll set it to 1,000 so that we will go ahead and say, okay, great, we'll take the points, but know that it should be 10 gig E. Router OSPF 10, and let's see what happens here. Auto cost, reference bandwidth, 1,000. And sure enough, it's giving me points. So the grading engine on this activity is actually not accurate. So router OSPF, not 109, I'm sorry about that. No router OSPF 109. Router OSPF 10, auto cost, reference bandwidth, 1,000. Yeah, and it continues to give us the points. So we will go with it knowing that that is not the correct answer, but we did see what the correct answer should actually be. Router OSPF 10, auto cost, reference bandwidth 1,000. And then finally, BC3, global config, router OSPF 10, auto cost, reference bandwidth, whoops, come back there, 1,000. But remember, it should be 10,000. All right, so the completion percentage, we're now at 80%. So it's asking me here, configure the OSPF cost value of P2P1 interface serial 011 to 50. And let's talk about why it might have us do that. So let's pull this router up. Let's see which interface that is. I believe it is the one going to P2P3. Do show IP interface brief. And so here we are, and it's talking about serial 011. This interface here, which is definitely this transit segment right here, the transit between P2P1 and P2P3. And so it's asking us to set the cost value to 50. Now, think about that for a second. When we set the cost value on that interface to 50, what this is going to do is it's going to make this path look less preferred than this path to reach all of these networks down here. Now, these networks over here, right, that we're not worried about those because this router right? This router right here is going to be the one that is our transit point into these networks. It's over here. And again, it's in the outbound direction that this cost is going to make a difference. So when P2P1 looks at the cost to reach the 192.168.12 and 3, it's going to see a superior, i.e. a lower cost coming this path through P2P2. And so and the reason I'm kind of pausing here is I'm trying to figure out why it is they're having us do this, because and again, we're only setting it here. If I was the network engineer here, I think I see what they might be thinking, which is there's two networks over here. So most of the traffic might, and this is a work group server, so most of the traffic may be coming back into the PC and the laptop, because I would put it on both sides to make sure we have a symmetric flow of traffic. So watch what I'm talking about. Let's see if Packet Tracer will cooperate here. So here's what we're going to do right now. So from PC3, let's bring PC3 back up here. So I'm going to trace to the workgroup server. So let's say trace route to the 192.168.3.14. And let's see where we go here. And actually, let's make it a little bit more readable. So we go to the 192.168.5.1, right? Remember, I'm on PC3, so there's my default gateway. So let's track the path here. So I come to 5.1, I go to 10.0.0.1, I go to 10.0.0.13, and then from here I go to 10.0.0.10. Now that's the path you would want it to go, and then we make it down to 3.14, right? Because that is the shortest path for me to get down to the workgroup server, right? I don't want to come out this way because then I'm coming down this link here and then I got to transit, I got to come north to south and then I got to go, we'll say west is left to right to get back over here. So this works out great right now, but let's go ahead and let's set the OSPF cost and let's see if anything changes. So let's get into interface serial and interface serial 011, and let's say IP OSPF cost of 50. Now let's come back to PC3 and let's rerun. It won't let me clear the screen. And let's rerun that trace route command and let's see what direction it takes us. So it takes us to the default gateway right here, and then to our designated router, our autonomous system boundary router, and then over here to the 10.0.0.13. Is that right? 10.0.0.13? Yep. And then it takes us down. So it still brings me down here to the 10.0.0.10. So we set the cost here, but it doesn't appear that it's impacted this flow of traffic, right? Down into that outbound flow down into this router. So I'm wondering why they've got us setting it, unless it's just that they want us to have, something for us to do to see if we know how to set that. And the configuration percentage, as you can see, went to 84%. All right, so we set the cost on that interface to 50. Now it says configure the hello and dead timer values on the interfaces that connect P2P1 and BC1 to be twice the default values. Now this makes clear sense to me because maybe this segment right here is a fractional T1. Even if it was a full T1, we've got a lot of gigabit connectivity back here that's trying to transit this link to get into the data services networks or to get to the internet. So we don't want lots and lots of OSPF hellos being sent back and forth on these links. So we're going to make that adjustment and we're going to throttle it back. And so this is a great use case as to when you would look to modify the defaults. So let's go ahead and I don't think I'm in the right interface. Which one is it? Interface serial 020? Yeah. Interface serial 020, we're going to say IP OSPF hello interval, and we're going to set it to twice the default, which is 20. And then remember, I need to set the dead interval in Packet Tracer. It's not auto-magically going to set it to 4 times the hello interval, so we've got to make sure that we take care of that. Let me save my config, and if I'm quick enough, I can do all of this. Do show IP interface brief, and it depends on how quick I'm going to be here. Interface serial 010, IP OSPF hello interval to 20, and IP OSPF dead interval to 80, and we did it, right? So we got it set on that interface, show IP OSPF neighbor. We missed it. So it took it down, but we will wait a second here and see if it comes back up, which it should here shortly. Let me stretch that out a little bit. So our adjacencies on the Gigabit Ethernet interfaces are still there. And there we go. All right, so I almost got it done in the dead interval time, but was not quick enough. So we had to wait for it to go down and come back up. But now you can see, here we go, and there is the dead timer. Again, it's counting down from 80 seconds, which would be 1 minute and 20 seconds. And so you should see it reset. Yeah, and you'll never see the 120, right? You're always going to see it like 1 second short of that. Whoops. Let me go ahead and get out of here. All right, so we are currently at 100%. That is the activity in its entirety. And remember, so we've got this little snafu here where it says the interface cost to be 10 for gig and 100 for fast Ethernet. The auto cost reference bandwidth would not be auto cost reference bandwidth 1,000 because the gigabit Ethernet interface would have a cost of 1. Because when you set it to 1,000, that is a gigabit interface. That now becomes your reference point in that calculation for the OSPF cost. All right, well, we have covered everything that we've talked about up to this point, not just in the course, but through all of these packet tracer activities. Again, we did a ton of work here. We configured router IDs. We used the network statement, subnet masking, wildcard mask calculation. We configured OSPF on interfaces. We manipulated the cost. We changed the hello and dead interval timers between the data services network and headquarters, because maybe that is a very slow link. We talked about the auto cost reference bandwidth and talked about not just how it's calculated, but what happens when you put in that 1,000, which is a gig. It doesn't magically change that interface to have a cost of 10 because it's a gig interface. It's going to have a cost of 1 if its speed is the reference bandwidth speed. So I'll open up a ticket for that and let Netacad know that there's either the grading engine's off or there's a typo in the requirement there on the right-hand side. Again, I can't thank you enough for watching. Have an amazing and safe holiday season, and I will see you in the next video. Have a great one. Thanks for watching. All the best.